Before we start, I have a very simple question for you. Can you tell me what time it is now, wherever you are in the world? This is a two-way screen, so I will hear you. I'm guessing that virtually everyone, either they looked at their watch or they looked at a phone or a computer or some other device, and whichever piece of technology you used, it told you the time. But how do you know it told you the truth? With most questions, you can double check the answer. But how do you check that the device is telling you the correct time? Would you use another device? Do you see the problem? Oh, and whatever time you think it is, I can tell you that it's probably wrong. I'll give you an example. Let's say that I'm in the Yorkshire Dales in England. So let me just get the Yorkshire Dales up. Right, I've got. So I'll put this latitude and longitude on the screen so you know where I'm talking about. It's August the 20th, and my watch tells me that it's 11:30 in the morning. But it's not 11:30, even though my watch says it is. That would make it 10:17 in the morning. So my watch is wrong. And this brings us to a deeper question. What actually is the time? And here I'm not talking about time itself. So let's not start waffling on about thermodynamics. I'm talking about the time. So when you say it's 5:30 or it's 20 minutes to 10, what do you actually mean? Now, a simple answer could be that we use a 24-hour clock. And as the Earth rotates approximately once every 24 hours, our clocks return to the same number at some point during each rotation. And the numbers indicate the time, But who decided that a certain point in the Earth's rotation should be 10:15, or 25 to 6, or midnight, or noon? The truth is, are you ready for this? The time displayed on your clock is ultimately determined by the system adopted by your government. They decide which time zone your country will use. And so that also, it dictates what numbers the clocks should display at a particular moment during the Earth's rotation. So when I asked you, what time is it now? Your answer wasn't really, it wasn't really the actual time. Your answer was simply a number that your government has decided it should be. Let me give you an example. I'm trying to think of one now. Oh, a very famous one. If you're standing at the Wakir Pass between China and Afghanistan, and it's exactly 12 noon, according to local Chinese time, if you take just one step across the border into Afghanistan, you haven't traveled through time, you haven't moved the Earth, you haven't even moved that very far, it's just one step. But that one step takes you to 8:30 in the morning. And the sun hasn't gone backwards by 3.5 hours, only the political definition of what the clock should say has changed. Or imagine, let's say that you wake up in New York. That's a famous one. You wake up at, I don't know what time people wake up in New York, 7 o'clock in the morning. And you call your friend in San Francisco. They will say, why are you calling me so early? It's only 4 o'clock in the morning. But you're both in the United States. You're both experiencing exactly the same moment. But your government-regulated clocks are telling you both different things. I think perhaps the most famous example of political meddling with time is, what's it called? Daylight saving time. Germany and Austria-Hungary, they were the first to introduce daylight saving time in, I think it was 1916, as a way of reducing the need for artificial light and conserving fuel during the war. Britain realized it was a really clever idea, so the UK did exactly the same a few weeks later, and they called it British summertime. And then not long after that, dozens of other countries started doing exactly the same. So the time on your watch, on your phone, on a computer has nothing to do with real time, or what a sundial would tell you. It's just telling you what time we have agreed that it is. And that agreement governs virtually all of your lives and our lives. We get out of bed, we eat lunch, we go to work, we go to school, we catch trains, we go to sleep, all based on the number that your clock shows you that has nothing to do with real time. Many people, me included, I like to think that I'm always making independent decisions. But in fact, our lives are being run by a government agreement, and maybe we don't even realize it. Now, don't misunderstand this. I'm not saying that it's a bad thing. We have to have some rules. I'm in England and we drive on the correct side of the road. Sorry about that. About 30% of countries drive on the correct side of the road, and the other 70% of countries in the world drive on the wrong side of the road. I'm going to get in trouble for that, aren't I? I mean, that's fair enough. Can you imagine the chaos that would be caused if everybody could just decide for themselves which side of the road they felt like driving on? So we do need some rules. But let's get back to what time is it and try to come up with the correct answer. Let's imagine that you're trying to think of a scenario here. I know, I keep getting told to write down what I'm going to say. I've got one for you. Let's say that you're an alien in a spacecraft and you're approaching Earth. You've been studying humans and you've discovered that we use a 24-hour clock and that each hour contains 60 minutes. But your alien civilization doesn't understand that our clocks are based on human political decisions. In fact, you thought humans were more intelligent than that. You don't care about human time zones or what each government has told their clock to say. You simply want to know one thing. What time is it at some point on Earth? To an alien or anyone looking at our planet from space, there are no countries, there are no political rules, there's no time zones, there's only a ball of rock spinning through space in the light of a star. If an alien wanted to know the time at any point on Earth, they would look at the sky to find the true answer. I've called it true time or the true answer because that's what a sundial would show. The sun doesn't care about human politicians and what they think or about saving fuel. In fact, solar time it's the ultimate truth of our planet's rhythm. When the sun reaches its highest point in the sky for that day, that is solar noon. But if you look at your watch at that exact moment, it will almost never say 12 o'clock. You see what I'm getting at? And the reason for this is that we use time zones. They're like giant invisible stripes that are painted down the globe. Every location inside a stripe shares exactly the same clock time. But because the sun appears to move across that wide stripe, it can only reach its highest point at solar noon, along one particular north-south line at a time. That peak movement only happens for people standing at the absolute center line of that time zone. So unless you're standing exactly on that line, your watch and the sun will disagree. So that's the bad news. Your watch is almost certainly wrong, and so is your phone timer, and so is your laptop, and so is everybody else's. But here's the good news. There's always some good news. It's not difficult to work out the real time, the correct time. So what I'll do is I'll use my phone and I'll show you how to work out what time it really is. So let's quickly go through the basics before we start. Oh, and it's been a long time since my school geometry lessons. So if I get anything wrong, let me know in the comments. So the first thing to understand about time zones. we need to understand them. And I suppose the simplest way to understand them, and I really do need simple because I'm not that clever, you need to remember that the Earth is a full circle. And I know it's not exactly, but today it is. It's 360 degrees round. And it takes, it takes 24 hours to spin around once. So, as I said, keeping it really simple. So the Earth is 360 degrees all the way around, and it rotates once every 24 hours. Now, if you divide 360 by 24, you get 15. So each 1 hour time zone is 15 degrees wide. And this means that it takes the sun 1 hour to cross each one of those stripes or time zones at 15 degrees of the total diameter of the Earth. Sorry, the circumference. I told you it's been a long time since my geometry classes. So you can break that down even further. There are, imagine this, there are 360 imaginary lines going between the North Pole and the South Pole. These are called lines of longitude. Now, each one of these is 1 degree to the east or west of the next one. And it takes the sun 4 minutes to cross 1 degree of longitude. Okay? The last thing we need to know about time zones is that each of them has a line of longitude running straight through its center. And that, what's it called? I think it's called the central meridian. If you are east of your time zone's central line, its central meridian, the sun reaches you, the sun will reach, it'll reach you earlier. Okay? And the true time is ahead of your watch. If you are to the west of the central line, the sun reaches you later. So the true time is behind your watch. Now, all this is very interesting. Well, to me it is. But let's get back to the original question. What time is it where you are at the moment? And you know what your watch tells you, but to get the true time, we need to actually figure out the gap between the sun and your watch, wherever you are in the world. Now, obviously, the quickest way would be to look at the sundial. But I don't have a sundial, so I'll show you how to check it out yourself. You just using the calculator on your mobile phone. Let me turn the calculator on. Hang on. Where's the calculator? See it somewhere? I've got a calculator. I have got a calculator. So there it is. So I've got a calculator on my phone, like this. The first thing we need to do is we need to find out where you are. Unless you're on the International Space Station, most people watching this video will be on the Earth somewhere. So we need to know exactly where you are. And I'm talking about east-west. Okay. So the first thing to do is open Google Maps. I'm assuming that most people have got Google Maps on their phone. Okay. Now open Google Maps on your phone and then press and hold the screen at the point where you are. And let's have a look. 2 numbers will pop up. For example, these will either be a positive, for example, 123, or negative, for example, -123. If the first number, that's your latitude, is negative, it means that you're south of the equator. If the second number, which is your longitude, is negative, it means that you are to the west of the world's prime meridian, 0 longitude. And that part, what's it? I think it passes through somewhere called the Airy Transit Circle, which is at the Royal Observatory in Greenwich in London. So today we can ignore the first number because we're only interested in how far east or west you are. So let's find somewhere. Where can I be today? Oh, here's a place. Let me zoom in a bit. Let's say that you're having a cup of tea at the White House in Washington, D.C. That's in America. So your phone will show you, let me try and memorize this. Your phone will show you 38.8977 and then another number minus 77.0365. That's what it says on my phone. The number we need today is minus 77.0365. Don't forget that because it's a negative number, you are 77.0365 degrees west of 0 longitude. Oh, and regardless of how many people say it, and regardless of how many YouTube videos are, the airy transit circle is not in the wrong place by over 100 meters. But that's a different video. Today, no waffle today, I'm going to stay focused. So now you know where you are, hopefully on Google Maps it'll tell you, relative to the 0 longitude. Okay, so if you want to go through that again, pause the video, press and hold where you are. Two numbers will appear, and it's the latitude and longitude. We're only interested in the second number. Okay, so you may want to write that number down. Next, what we need to do is we need to find the central meridian of your time zone. Where is the line going up and down the time zone that you're in? As I said, there are 24 equally spaced meridians around the world. These are, each one is an hour wide. These are imaginary lines that go between the North and South poles, and they run down the center of each time zone. To find your time zone is really simple. All you do is you divide your longitude by 15. Okay? I know, you're already asking, why 15? Well, don't forget that the world it's 360 degrees round, and our clocks have 24 hours. And 360 divided by 24 equals 15. So let's have a look. Let me open my calculator. Here we go, got my calculator. So we'll take our longitude, which is minus 77.0365. I'll divide that by 15, and you get 5.1358. Okay, 5.1358. But let's keep this simple. It's just a video. We'll keep this simple, and we'll round this to the nearest whole number, which gives you minus 5. Okay, so I'll delete that and I'll just put in minus 5. So this tells us that Washington in America is in UTC minus 5 time zone. Okay, UTC, I'm not going to get into that one. It was an argument between the French and the English, French speakers and English speakers a long time ago, but if you Google it, you'll get lots of information. Now, let's go back to stay focused. Now, multiply that minus 5 by 15, and you get 75. Now, sorry, you get minus 75. Because it's a negative number, the official center line for your time zone, where you are now, is 75 degrees west of Greenwich in London. Okay? So, now we know where you are and which time zone you're in. As you can see, well, hopefully, this is all really simple. If there's anything you didn't get at the first, just pause the video, go back, and you'll get it. You just need a phone calculator. It's not difficult. So don't forget that the time zone is based on the line running down the center. So if you may be exactly on that line, but it's extremely unlikely. So the next thing we need to do is we need to work out how far away you are from that reference meridian. How far away are you from the central line in your time zone, and also whether you're behind it to the west or in front of it to the east. Again, we'll use that same longitude number, which is, don't forget, minus 70, let me go back, I've forgotten it myself, minus 77.0365. Now you subtract the zone's central line. Don't forget, we already worked that out. That's minus 75. So minus 75 equals, and this gives us minus 2.0365. And this just tells us, because it's a minus number, that you are 2.0365 degrees west of the central line in your time zone. This is one of these things where it sounds more complicated than it really is. So you may have to go back. So the last section we need to remember is that the sun takes 4 minutes to cross 1 degree, as we went through that earlier on. So you multiply the distance by 4. So here we go. So that is, don't forget, it is 2.0365 times 4 equals 8.146 minutes. So the verdict so far, because when you're sitting having your cup of tea at the White House in America, because you're west of the central line of that time zone, you know, the geographic position of the White House puts the sun about 8 minutes behind the official clock on the president's wall. So the clock is is wrong by 8 minutes. And so that's it. That's as simple as that. Maybe not. Do we now know the real true solar time for anywhere on Earth? If only life was that simple. Have you noticed, maybe you have, that it gets colder in the winter and warmer in the summer? And the reason for that is that the Earth tilts on its axis and it moves around and does strange things. Also, remember, the Earth doesn't travel in a circle around the sun. I know that's what it shows in all the graphics, but that's not really the case. It actually travels in an oval shape, so it's not a perfect circle. And this, what we call it, seasonal tilt and cosmic shifting, causes the sun to run up to 16 minutes fast or 14 minutes slow, depending on the exact day of the year that you do all these calculations. But rather than explaining all the maths here, and to stop this video being 2 weeks long, later on, when I've got time, I will type up an explanation of how to account for the tilt of the Earth and the shape of its orbit, and I will put that in the bottom of the video description. So when somebody asks you what time it is, you can say, hang on, look at your watch, get your calculator out, start tapping some buttons. A few minutes later, you'll be able to say the real time. Anyway, I hope you found that interesting. Thanks for watching.